Hello everyone, my name is Thuruvan Thavapalan and today I'm gonna walk through chapter 3 and 4 of the Art of Network Penetration Testing. We are going to cover how to move from just knowing a computer is on to finding exactly how an attacker can get inside. So we are still in phase 1, the information gathering. Think of this like a heist movie. We have found the building, the host, which is on, and now we need to find every door and window, which are the services on the building, so that we can get inside the building. So our goal is to be thorough. Don't no need to rush to attack the first thing we see, like a service. If you see a service, it doesn't need to be an exploitable service, or we don't need to be exploited at that right moment. So we just need to gather information, map everything out first to avoid missing a better entry point. So this is our technical roadmap. We take our list of live IP addresses which we have done in the previous chapter, and we'll use Nmap to scan for open ports. This tells us what software is running, its version, and how it's configured. Finally, we use a script to organize all the data into a clean list based on the protocol, like a list for just web servers or just database. So we had to organize the results in order to utilize those results in an efficient way. Nmap is the industry standard for this task. Since there are over 65,000 possible ports, scanning everything at once can be slow. As a pro tip, we first run a quick sweep of the top 20 most common ports like 80 for web service, 445 for Windows file server, and many more. So this gives us immediate leads while the deeper and slower scan finish in the background. So as you see on the screenshot on the right side, we have scanned all the live hosts which we got from the previous chapter from port 22, 25, 53, 80, and some more, which are the like most common ports in a network. We don't just want to know if a port is open, we want to know exactly what is behind it. Using the -A flag, we can pull service banners that tell us, for example, that a server is running Microsoft IIS Low 10. This is a critical intel because different versions have different known weaknesses. For example, if their software they're using in an old version, so there's a public database which shows like for that specific version of software how many vulnerabilities are available to exploit. So if the host is using an outdated software, it's a good thing for us as an attacker, as these have public database of vulnerabilities which are exploitable. In a real company, you might find thousands of open ports. Reading that manually is impossible, and we are using a Ruby script called parse nmap to clean up messy Nmap files into a simple spreadsheet format. This will allow us to quickly group our targets, which is essential for the next phase. So as you see on the right side, we have used the XML file, which we got from the Nmap scanning, and then we use the parse Nmap to properly save those results in a tabular format. So as you can see on the first column, it shows the columns. It shows the first column, it shows the IPs. The second column, it shows the port number. And the third column shows the service running. And the fourth column shows the version of the service running. So now we move to chapter 4, vulnerability discovery. This is where we look for the path of least resistance. Instead of using noisy automated scanners like Nessus, which can crash system or miss details, we use manual tools like Metasploit and NetExec. This simulates a real thinking attacker who looks for specific flaws like weak password or missing patches. So our first major find involves patching vulnerabilities using NetEx. So we identified multiple Windows builds. We ran the Metasploit aiming on SMB MS17010, which is a known vulnerability for the specific version of the Windows. So we confirmed that the host 10.0.10.2 or 8 is likely vulnerable to the eternal blue vulnerability. So this could be a high priority entry point. So so next we tested credentials. I created a custom password list based on the company name by targeting the local administrator account, which doesn't lock out. And we had like 16 kind of passwords for like different combinations with password and then capsule corp, which is the the domain name. So we then applied this to the MySQL database where we specify the username, I guess. Yes, we specify the username for the Metasploit, but we tried to check the password. So Metasploit was able to get the password as the password.1, as you see on the screenshot on the right side. So finally, at the last stage, we analyzed the web interface surface. So in the book, they were using WebShot, but due to the updated Kali version, the WebShot couldn't work properly. So I have used GoWitness. It's like a similar tool. We can ingest, like we can try to map the website interfaces like GUI using the XML output of the Nmap we got in the previous stages. So I generated screenshots of every HTTP server on the network, HTTP or HTTPS server. It's like and this visual gallery allowed to immediately spot like a Jenkins portal and an Apache Tomcat manager pages running. So these were like gold mines because they often use default credentials like admin and admin, where we can then exploit them manually by going to their website. So before, without like trying to get whether that website has a GUI or not, we could use the GoWitness to check each of the IP and each of the specific ports, whether there's a GUI interface for that. And then if there's a GUI interface, we could just go there and then manually try the credentials. Sometimes the admin could work if they don't have proper security. So in summary, we have successfully mapped their network's entry points, identified critical vulnerabilities from unpatched Windows boxes to weak database credentials. So after this, I'll show you a live demo of the chapter 3 and chapter 4 process. So after we found the host, we have to figure out like what kind of entry point we can get inside the any system inside the network. So you can gather a lot of information. Let's say just like curl to the Reddit's machine in the Capsule Corp network. So we just do it. So you can see here this machine runs an HTTP server, and then you can see what kind of server is running. So you can see the Microsoft IIS 10.0, which where we can decide the server is running a 16, Windows Server 16. Just scan for all the machines with the common ports. So we have already talked about the common ports in the presentation slide. So common ports are like in general, these are the common ports that are always on the inner network. So we can do a simple nmap command. So we can do a simple nmap command like this. So we are scanning for these ports 22, 25, 53, 80, 443. These are like common ports that's are on Linux and Windows systems. 22 SSH, 53 DNS, 80 HTTP, 445 SMB server. So we are using the targets.txt where this where we have our scope, the scanning scope. So we just go here and then run the command again. So it took a while. There's a lot of ports, but we just specified few number of ports, so it just took like 5 seconds. So you could let's just go to one of the machines. So as you can see here, 10.209. So this is an Ubuntu machine. So you can see that 22 port is open, and then MySQL server is running on that machine. Let's just go for a Windows machine. So So here in this machine 10.2 or 3, you can see the AD port is open, which is HTTP and the HTTPS, and then HTTP proxy, which is running on 8080, which is Jenkins or Tomcat, I guess. We'll find that info in the last stage. So, and then next scan results under services quick sweep. So what that mean is we have the quick sweep GMAP and XML file, so where we can use the XML file to use on different tools to get some useful information. So first of all, we'll do services quick sweep dot grep open. So it's just a messy output, I think, because it saved everything as a one, and that's right. But you can see like the first 4 lines here for the first host. These ports are open, and then you see here on the second host 4553 is open. So let's scan the whole ports on all the machines. It will eventually take a lot of time, so let's see how long it takes. So this is the command, so we specify all the ports from 0 to 65,535, and this is the scope. Inside the target.txt we have the domain IP, sorry, the network IP, and we have mentioned minimum rate 50,000 packets at the same time, and then minimum host group as 22. So like it takes 22 machines each time when doing the scanning. So we'll just do the scanning and then wait for the results. So as you can see, the scanning is done, and it took around 2000 seconds, like 30 minutes. So let's go through some of the results. So you see here at for 209, the 22 SSH port is open, and even the Nmap tried to do an SSH connection onto that port, and then it got the SSH host key. So that's the benefit of having the -A option on the scanning. So this is kind of an like a powerful ultimate scanning. It will eventually take a lot of time. You can see like even for 11 hosts, it took like around 30 minutes, but if it like 10,000 hosts, it's gonna take a lot of time. So most of the companies firstly just do a quick scan with the common ports, and then they investigate on that scan while this scan is running, where they will investigate and get more info from the open port results from the common ports. So so after we got the results, the full sweep saved as GMAP and Nmap and XML file. So we can just do a quick search on what kind of script that scan has used. So we can use this command from the full sweep.nmap file. It shows only the script which it has used. So as you see here, it used HTTP, favicon, open proxy, server header, title, SSL date. So these are the script that the full sweep scan has used. So after the scanning is done, we saved those scan results in the full sweep.nmap things. So we here we just got the output of NSE script, which has been used during the full scanning. So here we can get a basic idea what kind of NSE script has been used during the scanning. So in this command, we can just inspect the like each of the NSE script, what kind of results it got. So as you see here, we don't have the info of the IP. We can use alternate rep command to see proper output. But I'll just explain like what kind of things we can have. So you can see here in one of the port machines. So using the NSE script, it revealed the IIS Windows server. So this thing will reveal that an exam server is running, and then this one says site doesn't have a title, but just some info. And you see here in this host, Apache Tomcat is running, and here IAS server is running, Apache 2 Ubuntu website server is running. So we'll get a basic idea of how the NSE script work. Just quickly check the XML file and let's see how it saves. So here you see for each of the hosts, it's like an HTML kind of like things. It's an XML language thing. So it's a lot of output here. So you can see here in the below, sorry. So the script is done here, done, and then it says port ID 47,000, and state is open. Recent sync acknowledgement is accepted, and then it says Microsoft is the server is running. So this is the format of the XML file, which we're gonna use on the other tools. One of the few tools you can use to like get the XML file in a good output format. So you can see with this output, you couldn't understand anything at all. So there's so many tools. So which we're gonna use is Parsmap. We have already installed it using the GitHub. I have shared the link in the description. So when you do Parsmap and then services, sorry, we just do parts and maps, services, full sweep.xml. It just takes some time and then it just reveals all the information. So you see here for 10.200, it says the 53, which the service is domain name system, and 88 curve roads. So you can see here it's like a proper output. So which we use this format to like save those files into a proper documentation as you see here, cat, and then it also reveals the output here. Like instead of doing the full port scanning, we can use like the specific port scanning. So you can just use this command to get the same results, which is enough for this network. We can actually save the pass nmap file into an CSV file format. So we use this format and then we can actually inspect the file. So we have a CSV file. And then using the grep command, we can easily like split those hosts into like smaller files. Let's say some hosts are running a web application, then we'll save that file in a. I'll show you right here. So you can see here inside the host we have web.txt. So inside that file we'll have the host IPs of which are running the web application, and then VNCs which are the machines which are running the VNC host. And then and then SSH, you can see inside the file we have the IPs of the hosts which are running the SSH service. So it's easy for us to use those files on the other scanning or brute forcing or like in the next phase. We have done with the phase 3 using the Nmap. We figure out the two, we have the host and services running. So So after we figure out the services running and their versions and all the information related to the services which are running on those machines, so there's this website is a public database where we can search for that specific version of the service vulnerabilities. So let's say as from the previous results we get to know the Apache Tomcat was version 7. So we'll just do a Tomcat 7. As you can see here, these are the vulnerabilities that can be exploited on a version 7. So it's just says 10.1. So before that version, these kind of before that version, this vulnerability can be exploited. So this is a public vulnerability database we can use to exploit a service. So in the next phase, we can use the NetExec to figure out the versions of the Windows, and then we can exploit it with a known vulnerability on that Windows. So like we can use NXE SMB. We can use the command NXE XMB discovery host windows.txt. So it will just run the attack like a scanning on the specific Windows host. So it says running in NetExec against the 9 targets. So and then it revealed the information here. So we could see here this machine has a Windows 7 Server 2008 7601 build. So which is kind of exploitable using the eternal blue vulnerability. So in the next phase, we will just within this version, you can use the public exploit the database or any public services to find the vulnerabilities which is on that specific version of the Windows machines. So let's exploit that machine using the uh, Metasploit console. So we'll just run the Metasploit console and then use auxiliary scanner SMB MS0. So this is the vulnerability version. So we just do press enter and then set our host file. This is the host file, so which is so it's a long name host Windows, and then we'll just run it. So as you see here, .208, it reveals like the host is likely vulnerable to this eternal blue vulnerability. So let's create a password.txt which has the common password. So I have more like some modification of password, just a text password, and then using the domain names, which is capsule. So I have already created. I'll just show it to you. So as you can see here, we have some username here, and then some different combination of password here, and then cap the domain thing here. We can specify this. We can use a big list of password, and then we can use that password list. So these are like common for the domains most of the times. So if they use a simple password, which is so we can just exploit them. So we can use this by a txt file anywhere in the Metasploit console or in any tools to brute force. So after we creating so using the netx file, we can brute force all Windows host using the for SMB. So NXE SMB. So it just brute forcing the SMB port of all the Windows machine using the username administrator and the password as in the list. So it will just try all different versions here. So we just press enter. It says scanning against 9 hosts. So we'll just go. So you see here this machine 10.0.10.202, which is is brute forced with the password as you see here. So which within this information we can brute force the network on a specific port. So if you think the brute force attack here, whether it logs, whether it makes traffic on the destination machine and the internal network, whether have the logs of us or like us trying to brute force it. Absolutely yes, they will have all the logs related to brute forcing, so it will trigger their system like uh, so let's use the Metasploit console to review brute force on the MS Microsoft Server SQL. So we'll use MSF console. We just run it and then we just use auxiliary scanner MSSQL login. So we can see the options by using show options. So whether it's compulsory required or not, it's here. So we just need to specify the password file, which is the password.txt, and then host file, yes, and then a username. So we'll just specify the standard username here. So set username SA, set our host file labs capsule discovery host MSSQL host. Okay, set pass file labs capsule password.txt, yes, and then we'll just run it. As you can see here with the username, it tried different combinations. So this is the only machine which was running the Microsoft SQL Server. So as you can see here, the login was successful for this username password combination. So here if the MySQL server is configured to use XP CMD shell configuration, we can even remotely execute any Windows command using the MySQL server. So which we'll explore in the. So similar way, next we can try to exploit the weak password of the MySQL servers running. So same way, use auxiliary scanner MySQL login. Say our host file. That you call. Then discovery host MySQL. Yes. Let's say first file desktop that that you that you call passwords.txt. We'll just run. So this is the results. In this phase, we haven't specified a username here because the default MySQL username is root. So as it already Metasploit uses. But here you can see, so here you got the results unsupported target version of MySQL detected. So there could be two meaning for this. One meaning the meaning as it said, the version that MySQL server is running, it's not compatible with the Metasploit scanner, or some other way the MySQL server is set to log in only using the local loopback address. So like only within the local machine, the user can log into the credential, log into the MySQL server. So from a remote machine in the network, we can make a login. So we can verify that we can use Medusa. So this is the command. I'll just copy and paste it. So we run the command against those MySQL host. So here you can see the error message failed to retrieve server version. Host is not allowed to connect to this MariaDB server. So from this thing, we can find it like the MySQL server is set to log in only from the local machine, not from any other machines. Well, next, let's try to brute force the VNC server. So VNC is like a remote management service. Even though the VNC is not encrypted and doesn't align with the central authentication system, it's very common to see on a network pen test. So we have found some VNC servers running on some of the hosts. So what we can do is we can exploit brute force the VNC host. So as you see here, we'll just use auxiliary scanner VNC VNC login. Let's say our host labs, as you go, and then discovery host, VNC host, that hotspot, so.txt, yes. Then we run the brute force against it. So it says scan two of two hosts, and then we just go through the thing. So we could see login successful with the password admin. So here also two machines running the VNC, and they both have the password as the admin. So let's discover some configuration vulnerabilities. So which means, let's say for example, let's take the Apache Tomcat. So when the Tomcat is running, let's say someone got access to the Tomcat management panel using a brute force or any kind of traffic. So they can get into the Tomcat and then upload a web application archive file. So which even gets attacker who gains the management portal to get remote access even to the host machine. For that, we don't need to go through each of the host which has a web portal and then try to brute force it or like log in it. So what can we do is we can use WebShore as in the book, but WebShore may not work as described in the book for some many reasons because the carry is updated and they don't have packages which are aligned with nowadays. So instead of that, we can use a different tool which is GoWitness. So this also does the same thing. It uses the Nmap XML command and then go through all the four their web servers running and then like try to see whether it has a GUI version of web portal and then it will just put some screenshots. So as you see here, this is the command we have to use. So where we are specifying to GoWitness to scan using the Nmap file, which is where we specify the web.xml file where it has the web host and then document the screenshot inside this directory and then screenshot format is sorry PNG and then screenshot the full page. So we'll just run it. There's a typo. We'll just change it. So we just run that command. So and then you can see the output here. You can see the output here. So it says it went to this IP on port 80 and then it could see got the screenshot true and then it went to the Apache Tomcat and then it says have screenshot and true. So we'll just keep running it and we can just go to this directory and then screenshot one. Then you can see the images here. So you can see here This one is the IAS server, and here you can see Jenkins, Apache, batch request, and then this is the Apache login. So you can see the IP and the port here. So we can just go to the Apache. So it says 10.203.80. So 10.0.203.80. So this is the IP. So we'll go to here and then we can manually brute force the website, or we can use softwares like Burpsuit to like brute force in a GUI web interface. We have already logged in, that's why it just went through. We can try, otherwise it will ask password, so we can I can show you in a private window. So it's asking for username, so we already know the username and password. It's the admin. So using this manager panel, they can upload some WAR files, which is web application archive file, and then the attacker can even get a remote access to the host machine, which is running the Tomcat. So after that, we can see Jenkins and some other tools. And Jenkins 202.80, and then we can go here 10.10, 202.80, sorry, 202.80.80, and then we can either brute force it with username and password using the burp suite, or we can manually try some password. So just the password we already gave, we know. So here they can create a pipeline using the Jenkins, and then they really like make a pipeline that sends some like system data to an attacker. So this is all for the chapter 4, which is discovery, chapter 3 and chapter. This is all, and so this is all for the chapter 3 and 4, service discovery and then vulnerability discovery. So that's the end of the chapter 3 and 4 of the art of network pen testing. So in the next phase, we will get into focus penetration, and we'll get deeper into the exploited vulnerabilities, exploited weak passwords, and the web applications. Thank you for watching.